Alright, welcome back. On this video, I'm going to show you how to do this reverse curve, equal radius. So it doesn't really show that here, but they're equal radius. And this one is the same. On between two non-parallel lines, parallel lines given the point of PC, the point of point of curvature, point of tangency, and then calculate where the point of reverse curve is, and with just the radius, is you can do that because you'll come out to this is going to be perpendicular, so it's easy to locate, and then swing your arcs till they intersect. And this guy, his name's Sujin George, put a video out, kind of explained how to get these angles, which is very clean. So I'm going to just go through the process here. You have this angle 47.5, because what it will do is we'll put it into Excel, right? And then that's kind of the key to make sure it's automated. So there's your 47.5, 25.2. That's this angle here, 25.2. I'm going to zoom in a bit. 25.2, 47.5. And then you have the distance, which is measured or calculated here, 720. And then you're going to, we're going to just draw these with the actual dimensions, and then the calculations will have the dimensions in them. And the last step is the sine of this plus the sine of the sine of the two angles. We'll call that, I think he calls it del 1 and del 2. And then 2 times, and you're going to just add those together with the 2 times the cosine of this angle here, the one that's calculated. So that's this cosine of that, and the cosine of this, and then you get the arc sine of those two combined and divided by 2. And maybe I'll show how that gets calculated. But he does it pretty well right there. So you just kind of go through, you run the perpendiculars, and then since this becomes a rectangle, right? You can calculate this angle to this one, and then calculate that angle there. And he does a real good job. So if you're interested, watch that. It's his name is Sujin George, and it's a video on reverse curves. And with that, you can calculate 90 minus that. He goes through that process real well, so if you're interested. And this is the same one that he uses here in this example, the same numbers and same angles. And then you can calculate this. Actually, that's just the same angle here. And then the same angle here is this one, right? So now you have this full angle, right? And this full angle, you can calculate the length of the curve here, and the length of the curve there. It goes through those processes, right? And then the thing that snagged me up, it took me a while to figure out, was how to get the length of this radius from that information. So what I did was just bring it in. So you're getting the sine of that 25.25, and what you do is you make the diagonal of that sine of 25.1. So that becomes the sine of, that's actually, if you type in your calculator, sine of 42.58. Let's just do that, show you tools with no length. It becomes, because that's like the sine of 25.2, close parenthesis, enter, becomes 2.4258, right? And that's because this length of the diagonal is 1. And then you do the same thing here. This angle here is 1. The diagonal of this is also 1. Right, so you get this sine of this angle ends up being that. So what it's going to give you is a ratio with these angles to that diagonal, right? depending on the length of that. So what would, and then you get this angle, and then this is the cosine of 2 times. So let's do this. V right there is F4. That's the middle of, I'll show you why. JHA. JAA. Okay, enter. So what's up with that is this here is also 1. And this 2, right? So it's, this triangle is twice as long with the diagonal being 2. So you double that up. And what you end up with, let me get rid of those, is this length is the sine of that. This is 2 times the cosine of this 52 because it's the adjacent side. And then this here is the sine of 25.25. So if you add that, that, and that, that becomes the ratio if all with those angles, if all these are 1. So what you'll do is you'll take this, if this is 720, this one here, let's say this was 720, right? You're going to divide 720 by that, and that will give you the equivalent 1. Because see, like right here, this is 2. This is the all those added up. If I'm sorry to put that there, but if you add those up, you end up with 2.3887. And if the diagonal here was 2.3887, you would end up with 1. So the total length divided by that ratio number, and in this case it's 1. So let's go up there, Control W. So this won't change, this 2.38. I don't know why I didn't write that down there. So let's do that. 2.3, let's go over here. 2. Did I write it down? Yeah. Control C. Control V. And then what you do is you divide the 720 by that number, and you'll end up with 301.4151. Right? So let's go back to Excel and kind of go through it there. So I put all these like in red to show you where this red angle came from. The green is just adding and subtracting and calculating which angles are what do you call it, complementary, and then adding them up. I didn't put the added ones there, but if you wanted to add those up, you could calculate the length here and the angle there, and you could calculate the radius or the lengths. He does that in his video. And then here's the 2.38, right? And if you take this last one, and it's 720 divided by that number, and it'll give you 301.41, and you have your radiuses. So from point of tangency, point of curvature, if you come out there perpendicular, you got point A. And if you do the same thing over here, perpendicular, same distance, point of tangency, and then you'll end up with 2 times that radius in between those 2 points to close out. And that was it. So let's go through here real quick, and I'll just scroll through these. So there's angle A, angle B, or delta 1 and delta 2, or whatever you call them. And then you get your 720 as your diagonal. This is how you get the cosine of A2, that one there, as you type cosine radians. Same thing here, cosine radians would be 2. And then here's just adding those 2 up and dividing it by 2. And that's how you calculate the degree. The arc sine of that will give you this 52. And then there's your complementary angle. And then this is the adding this one to the, adding the angles up. E4 plus A2. A2, so you're adding those and you're getting those big angles right here. 80, I'll zoom in. Not zoom in like that. 85 and 62. So you get those, that's how you'd use that. And then you take this, once you calculate the radius, you calculate the lengths. And then here's how you get the sine of A2. Yeah, this is just the same angle as getting the sine, and cosine, doubling the cosine right there for this distance here, right? And then you get the ratio, and then you divide the ratio. 700, you divide this diagonal, that total length of the diagonal, by that ratio, and you'll get your radius. All right, and I one of the reasons why I put these videos out, not just to remember, but to learn, you know, to figure these out so that I can share the solutions. And down the road, when I remember, oh, I know how to do that, and I forget, I can come back and watch the video. So I hope this helps you in your career. And yeah, try subscribe and give them a thumbs up if you think these are going to be helpful in your career. And thanks for watching.